Welcome everyone. My name is Caitlin Metcalfe and I'm the Product Manager of Engineering Analysis here at ALLPLAN. I hope you're enjoying the ALLPLAN Build the Future Summit so far. I'm a licensed civil engineer out of California, USA, and I have over 15 years of experience with structural engineering. I'm especially passionate about connection design and the critical role it plays in every project and every structure we work on. So I'm honored to bring you this presentation on how to engineer a better and more complete structural connection. With this presentation, we'll have a look at what it means to have a complete structural connection design, current workflows used today, and the problems they commonly create. Then, we will look at how you can use SDS2 by ALLPLAN to design better, more complete structural steel connections. We'll also investigate ways that you can improve team coordination through the collaborative BIM Plus environment. I'm very excited to share these solutions with you. So let's get into how we can help improve your workflows today. What is a complete structural connection? What do I really mean by saying complete? We all know that designing structural connections can be a tedious and inefficient, repetitive process. But it is, of course, a very important part of the structural design and can often uncover issues with the project overall. Therefore, it is one that requires great focus and consideration throughout every phase of design from start to finish. That is why I'm careful to speak about the structural connection design as a complete process, considering much more than just the design calculations. While it certainly is important and the first thing we all check, checking the design code required limit states is not the complete story. We must also consider material availability, shop preferences, and most importantly, the constructability of the full three-dimensional node. Can our designs actually be constructed? Constructibility includes both buildability and erectability. Buildability means, can my connection be constructed in the shop? For example, is there clearance enough to weld a plate in between a shallow column's flanges? Erectability means, can my connection be erected on site? Do I need to coat back bottom beam flanges in order to drop a beam into position? Is there room at the connection to tighten the field bolts? I'm sure I'm not the only one guilty of designing an unbuildable connection at some point in my career. Unfortunately, doing so not only causes distrust in the overall engineering design, but also a lot of time and money lost to redesigning. Not to mention the added stress and pressure on our already full schedule. It's critical that as we grow in technology and experience, we consider each of these areas equally important when designing structural connections. So how can we improve today? Engineering structural connections takes up a lot of our time and demands detail and focus. With all of us already being crunched for time on every project we do, how can we improve this process for a safer and more time-efficient workflow? To better understand the solution, let's look first at the problematic conventional workflow that is commonly used today. As any project runs through the structural design, many components of the design run in parallel. First, the BIM model is created based on the architectural or as-built drawings. From this, the structural analysis models are created. Many times, we separate this work to multiple design teams, so the models may even be split into gravity elements and lateral elements. The structural design is run, possibly several times, and usually with several design updates. And revisions are then sent back to the drafter as markups to the original BIM model. Now, most structural analysis programs do not account for connection design. So from these initial analysis models, we have to manually take the required member end loading and build our connection design models or calculations separately. Again, any design updates are sent back to the BIM model with manual sketches or markups for the drafter. This is a long and very labor-intensive process. But once complete, the structural drawings can be created, followed by the fabrication model, shop drawings, and construction drawings. Of course, none of this is a one-way process, and we all know our designs and models will be revised over and over throughout the approval process. And of course, with any RFIs or requests for information that come through after the design is considered complete. Not only is this process very manual and repetitive, but it also can result in 5 or more design models. So much unnecessary work is being done in parallel. It goes without saying that this current workflow is incredibly inefficient and still results in an incomplete and problematic design. Multiple analysis and design models. All will be a little bit different, and rarely do they accurately align with one another. Lost ownership. With so many models, there is no single source of truth, nor is there a person, let alone a group of people, who understand all the software assumptions and limitations to be able to recognize the proper way to interact with each other. Typical design connection processes are inefficient, not convenient for repetitive designs, like connection design. And most do not include automated optimization. This all results in an over-designed and possibly even wasteful design calculation. So what is the cost of all this inefficiency? Let's take a look at the true cost of RFIs, requests for information, and change orders. RFIs, or requests for information documents, are simple, right? A basic request for clarification among the design team members. But there's really nothing simple about them. They can cost us all a lot of time, frustration, and money. Research by the ASCE Press has shown that 90% of all major construction projects struggle with budget and schedule overruns. This is no doubt contributing to the large number of final design decisions and team coordination that must happen last minute, while we're all rushed and out of budget during the construction administration phase of a project. The problem is that this process can be very expensive, whether at the end of the process or earlier. The average large project has over 15 RFIs per day, and each one can cost the design team over $1,000 to respond to. Even worse, 1 out of every 4 RFIs receives no reply. This lack of communication and coordination leads directly to distrust and dysfunction among the team, construction errors, and even a potentially unsafe structure. To avoid this costly process, we must aim to coordinate, communicate, and ask for each other's input earlier in the design phase. We must work together to address these issues now. So what is a tool that can be used today to head these issues face-on? SDS2 by ALLPLAN is your tool. SDS2 by ALLPLAN is the industry leader in steel detailing and fabrication, and its best kept secret, that's not really a secret, is that it is also the best tool available to engineer steel connections. SDS2 has over 40 years of experience and is used by detailers, fabricators, erectors, general contractors, and structural engineers around the world. It has over 650 base connection types that can be modified and customized to whatever design parameters you need. And the connection design is backed up by full connection design calculations for 20 global design codes. SDS2's unique solution allows you to input design parameters to control the optimization and design of your connections. You can control the region, design code, and design method when applicable. You can also set up the default connection design settings to control the automated design of the connections. Then, as you model, connections are generated and automatically checked at every node. SDS2 includes structural connection design. It checks all applicable limit states per your selected design code and verifies the constructability of every node in all 3 dimensions. There's no more need to manually check oversimplified 2D typical connections. With SDS2, you get the most optimal and efficient design for a fabrication-ready connection. This design is then supported by complete output reports. Once designed, the 3-dimensional connection cube will detail your connection, giving you automatically generated 2D sketch drawing details of the connections at the node. These drawings can be edited to your office standards within SDS2 and then exported as part of the design package. The connection cube can easily generate a full connection report with complete calculations and detailed drawings in a customizable PDF report. The 2D sketch detailed drawings help define the connection geometry, as does the fully customizable 3D view. Design results are then presented in both summary tables and also in a fully expanded format so you can see every calculation and resulting design choice. Once you have used SDS2 by ALLPLAN to design your structural steel connections in record time and accuracy, it's time to collaborate. The structural engineer cannot work alone, so it is critical that coordination with the design team is done early and often. The tool for this collaboration is BIM Plus by ALLPLAN. BIM Plus is a cloud-based collaborative model environment which may be used to coordinate with teammates and their design models. In minutes, your SDS2 model can be uploaded to BIM Plus, where you can share and manage project data, clash detection, issue management, and team discussion in a secure web-based environment that can be accessed anywhere and at any time. Using SDS2 in combination with BIM Plus allows your team to provide quick, accurate designs while easily building trust and offering open communication among your team. Both of these platforms encourage team collaboration in order to provide the best project experience for all. The earlier we begin to communicate in this way, on common ground and using common design tools, the better overall process will be for all of us. Properly integrated or partnered teams build trust and open communication early, which results in fewer RFIs, more satisfying teamwork, faster delivery schedules, and of course, cost savings for all. So what is the future in complete connection design, and where will we all go together as an industry? I encourage all of you to review your current work processes and look for ways to provide more accurate, safer designs while working closer with your team. The faster our industry advances, the faster all of our schedules have become. So it's key for us to adjust to more efficient workflows for improved project delivery. Better collaboration means better design teams and better project performance. Simplified, cloud-based tools for engineering and coordination give us all more options for design and better support for the need for collaboration. And of course, continued engagement with the global structural engineering industry so we can all learn together from industry trends and up-to-date connection standards. Use SDS2, BIM Plus, and the entire ALLPLAN suite of products to bring your team closer together for stronger, safer, and more eco-friendly structural connection designs. These are the tools that we can all rely on for improved design and improved budget schedules, which help make steel connection design a more focused, safer, and more economical process for everyone involved. Build the future of our world and the future of your connection design with ease and confidence. Thank you for listening. I hope you enjoy the rest of ALLPLAN's Build the Future Summit.